area right here, you'll be able to see your heart just slowly pulsate. That's because of the heat that it's generating. Firefighters use this type of technology to fight fire nowadays, and what they'll do is they'll point an infrared camera toward the fire and they'll find the hot spots in the building, but more importantly, they'll also be able to figure out where people are so they can focus their rescue efforts right to where the people are and get them out more quickly than if they have to go in and search an entire building. This over here is our relative gravity display, so we have a full can of Coke right here represented on Earth, the Moon, Jupiter, and the Sun. So if you put your fingers under here and gently lift it, you'll see that on Earth this weighs about a pound. On the Moon it's about 1/7 of a pound. In Jupiter it weighs about 2.5 to 3 pounds. On the Sun it would weigh about 1,000,000 pounds, and of course we can't put anything that weighs 1,000,000 pounds in the trailer, but we got a pretty heavy weight under there to simulate it. This over here we're kind of proud of is a tile from the space shuttle. It's actually a real one, and NASA gave it to us. This thing is very heat resistant. It will take temperatures over 10,000 degrees Fahrenheit. You can use the hottest blowtorch on Earth across that thing, and the worst it'll do is scorch it. It'll never burn. This right here is our airlock to simulate what it would be like in outer space, which of course is a vacuum. And so we have a rubber glove in there, and we're going to pretend that's our astronaut. He's testing a spacesuit for us. And now if it's a good spacesuit, it won't puff up like it's doing right now. It would maintain his shape by putting 14.7 pounds per square inch all over his body. You can see he's puffing up. We need to get him out. And of course we can't pull it with this handle right here with this vacuum going on, so we need to shut this back down, pull it up, and then we're going to go ahead and check him out, and he's okay. This over here is a really cool video that we have about solar flares. Solar flares are enormous explosions on the surface of the sun. They're more than 1,000 times more powerful than the most powerful nuclear explosion we have here on Earth. They will reach as much as 10,000 miles out away from the surface of the sun. Now keep in mind the sun is there's some right there. Now keep in mind the sun is some 93 million miles away from Earth. But even though it's that far away, this still affects us here on Earth. Among other things, it can cause warming spells on the Earth, and it can also cause a whole lot of communications interference. So you might be watching your favorite football game on Sunday, and all of a sudden you start hearing a bunch of interference. That could be solar flares affecting the television signal that you're getting. Okay, or maybe you're sitting there talking on your cell phone with 5 bars, and all of a sudden it drops the call. It very easily could be some interference from the sun that's causing that. This next station is our energy station, and our first exhibit demonstrates how you can take mechanical energy, which means something's turning, and convert it into electrical energy by spinning this bicycle wheel around and round, and we get this generator going so it can generate some electricity. We have 3 different kind of bulbs here. We have the LED over here, an incandescent, and a halogen. So let's see what lights up first and what lights up last, and we can determine which one type of bulb is going to need the most energy. So we just barely get this going, and the LED lights up right away, so we know that's going to take the least energy. We're going to pump a little bit faster, and now you can see the halogen coming to light, so it needs more energy. And if we go really fast, you can see the incandescent starting to glow a little bit. So it would take a whole lot of energy to get the incandescent going. So your option in your house would be to go with LED. The bulbs are very expensive, but they typically last over 10 years, and the energy consumption is so low that you save a whole lot of energy. Another way you can save energy in your home is to insulate. In the Trailblazer, we have 4 inches worth of insulation all over the walls, the floors, the ceilings. And right here is the exterior skin of Trailblazer. If you touch it right there, you can feel that it's warm from the temperature outside. That's how we're able to keep it nice and pleasant in here in the Trailblazer. This over here is our fuel cell card. On the red side over here we have water, so we pump some water into the fuel cell, and it breaks the H2O down into hydrogen and oxygen. And of course hydrogen is flammable, so we can use it as a power source. On this side we have vegetable oil, like what they add into diesel fuel these days. So it becomes biodiesel. We can recycle the oil from places like McDonald's, Burger King, and places like that. So we're going to flip our switch over here and allow it to charge up our batteries here from our fuel cells that we just put those liquids into. And then we're going to flip it back the other way, and it gets our fuel cell card moving for us. This right here is a new addition to Trailblazer. It's a sunroof up on top. It goes through this light tunnel right here, and the sunlight diffuses itself in this really cool lenses right here. This is not electric light. This is sunlight coming from outside. You can buy these at the larger home improvement stores like Lowe's and Home Depot, and you can put that in your bathroom or in your kitchen, and it's a good source of light, not having to put electric lights on all the time to be able to see. So we have light energy from the sun hitting the solar panel right here, changing it from light energy into electrical energy. It's doing two things. It's charging batteries that we have in there, and we can flip the switch and it'll run this little motor right here for us indefinitely as long as we have sunlight coming in. If it's nighttime, we can count on our batteries to carry us through, because we've stored up the extra energy in those batteries throughout the day. This right here is a mock-up of a wind turbine, like the really huge ones you just see all over Texas these days. So we're going to get this thing spinning for us, and we're going to give it a little bit of burst of air to simulate the wind. And you can see a reading right here of about 0.2 volts. And that's not a whole lot, but the full-size ones that you see all over Texas these days will generate enough electricity for 500 to 1,000 homes for each one. I live in Schulenburg, population 2,831. If we had one of the full-size wind turbines, we could power the entire city with that one wind turbine. And this is our chromatography display. Chromatography simply means that you can separate out different chemicals and be able to identify them. And there's a variety of ways that you can do it. This right here represents particle separation, and so we're using wiffle balls as a form of filtering. And so we can flip this over, and you can see separation of the green, the yellow, and we have a red-orange ball back over here. So if you were working in a CSI lab and a body came in and you wanted to determine whether they had died of poisoning, you could separate those chemicals out, pull those chemicals once they're separated, put them under a microscope, and determine what kind of chemicals you were dealing with, or run other tests on them to identify them. This over here is our high-definition digital microscope. It's digital because it also plugs into a computer, and so the students have the opportunity to look in through the lenses and see the slide that you can also see up here on the television computer monitor. This is a human hair follicle. What you see all around the hair follicle are skin and nerve cells, and then right here it roots into the skin. So if you were to pluck a hair out, like an eyebrow or an eyelash or whatever, you would rupture all those cells, and that's why it would hurt when you take it out. Okay, so this right here is all about DNA sequencing. I'm sure you've seen DNA pictures on TV before. It's a really cool looking ladder-like thing, and it spirals. Well, if you untwisted that and made it flat and converted those into letters like this, you would get a DNA sequence. And a genetic scientist could look at this and make total sense of all these letters and stuff. So this is a sequence for a normal human DNA. So we're going to take this right here and see if we can discover a mutation. We're going to overlay them, and you'll see right through this area right here, there's some variation. That's where the mutation occurs. Mutations can be positive things, or they can be negative things. For example, if you had a mutation that caused you to have a little bit less of a propensity to get cancer, that would be a really good thing. But if you had a mutation that caused you to be autistic, that wouldn't be too good of a thing. So genetic scientists are always studying DNA sequences to see if they can figure ways to manipulate those and stop people from having such horrible lives and make their lives a lot more pleasant and healthier. This right here is a really cool video we have of robotic surgery. Robotic surgery is kind of cool in that you can just put 3 or 4 very small one-stitch incisions into somebody, and you put your instruments in 2 of those holes and stick a camera in another one. Right here you see this doctor is manipulating the controls for this robotic surgery, and he's operating on this patient over here. Nowadays, I hear they've been doing some experimentation with doctors being in one city and the patient being in another, and being able to operate them on them. I always say if you're going to get robotic surgery done these days, you want to make sure your surgeon used to be really good at video games. Right here you can see they're doing some work inside the human body. I'm not sure exactly what that is. It looks kind of like a tonsil. I'll have to check that out and find out. Oh, uterine preserving myomectomy. I'm not sure what that is. There's a Dremel type tool right there. What they're doing is they're going through fat in the body. Everybody's body's got some fat in it, and it's a necessary part of your physiology. And they're going to go inside there so they can do some repairs. This section right here is our weather section, and our first exhibit is about greenhouse gases. So earlier today I introduced some CO2 to simulate pollution in this jar, and this is just nice clean air. And if we put our digital thermometer and check the Earth's temperature, we got 111.0 over here, and over here we have, it's not in the right place, 111.5. That means we have a half a degree increase in the temperature right here, just because we have a little bitty squirt of pollution. So the more pollution you have, the more heating you're going to get out of it. Okay, that's the greenhouse gas effect. I bet you're wondering why we have a cross-section of a tree in a weather station. The reason is that if you take this magnifying glass and look, you'll see some of these rings are very thin and some of them are much thicker. The thin ones represent times whenever this tree, the region where this tree was, had less rainfall. The thicker ones represent times when they had more rainfall. So you can see for the last 25 or 30 years of this tree's life, there wasn't very much rainfall. But prior to that, there was quite a bit. There was a decrease in rainfall here. When the tree was first planted, there was quite a bit of rainfall happening. So we can go through the history of that particular area and find out what kind of climate they had going. This right here is an andrometer. It measures the wind speed, and so if we get this air blowing off, if we get this going really, really fast, we would end up being able to measure that wind speed with this device right here. These are some really old weather instruments. This one right here dates back to prior to the time of Christ, and the way it worked is those various colors moved at different positions, and you can determine the temperature from there. This is an old-fashioned barometer. Whenever the barometric pressure increases, it usually means that you're going to go into fair weather. When it decreases, that usually means you're going to have some bad weather. For example, when a hurricane's approaching closer and closer, your barometric pressure keeps dropping. We can affect this thing by actually touching it. You see how it climbs whenever I touch it. It's over here's a plasma ball, and if you put your finger on it and move it around, you see how it follows your finger. The reason it does that is because the human body is 70% water. Water is a really good conductor of electricity. So today you can go home and tell your friends, I held a tornado in my hand, so what did you do? So you can feel the vibration from the bottle whenever I hand that to you. That's why when people describe a tornado, they often say it sounded and felt like a freight train coming. It sets up a really powerful vibration when it does that. We're going to next section. We have two wind tunnels here, and engineers can use these to determine the best weight and shape for objects that are going to be subjected to wind. For example, cars, motorcycles, planes, trains, boats, anything at all. So you can get two various shapes. You can see this one is tapered and this one is not. So I can push it up in here, and you can see how they're affected differently by the wind. See, this one wants to come out pretty quickly because it's getting a lot of wind resistance. That wind resistance is pushing it out. This one's staying quite a bit lower because it's tapered right here on the one end. And so the wind's not affecting it as adversely. I think we lost our air. So this right here is a demonstration of the Bernoulli principle for wings. So we always tell the students, put your muscles up and say slower is stronger, faster is weaker. So basically what happens is the faster, weaker, lower pressure air goes on the top of the wing. The slower, higher pressure air is underneath the wing, and that's what lifts the airplane up off the ground. to demonstrate that, you can take a piece of paper, fold it over, let it flip over like this and blow real hard on top, and you see how it picks the wing up. Because I'm not blowing on the bottom, so the slower air at the bottom is stronger than the faster air I create at the top, and that picks the wing up. Here's another example of the Bernoulli principle. We have air coming out of this PVC tube. You'll notice if I move it around and tilt it, the ball still stays on top. What's happening here is we have fast air hitting the bottom of the ball. As it begins to go around the sides, it slows down just a little bit, like when you turn your bike around a corner. And if you feel right here, you feel fast, weak air here, and slower, stronger air here. You can do the same thing at home with a hair dryer and a ping pong ball. You take the hair dryer and point it straight up and down. Take a ping pong ball, release it about 12 inches above the outlet of the hair dryer, and it'll stay floating. Then you slowly move the hair dryer around, and the ping pong ball will follow you around. So that's when you can do it home quite easily to demonstrate the same thing. Over here is an additional part of our weather station. We have our weather broadcast, so we have a green screen just like you would have in a TV station back here, and we're projecting this map of Texas onto the screen through the camera, and you can see that it's not exactly an easy thing to be able to point to these things like the weather guy does. This is the same thing he's doing. He's looking at his monitor. He's not seeing this map behind him. He's only seeing the map on the TV screen.